Distribution of lightning. The distribution of lightning, or the incidence of individual strikes in any particular place, is highly dependent on its location, climate, and time of year. Lightning does have an underlying spatial distribution. High-quality lightning data has only recently become available, but the data indicates that lightning occurs on average 44 plus 5 times every second over the entire Earth, making a total of about 1.4 billion flashes per year. Ratios of lightning types. The lightning flash rate averaged over the Earth for intra-cloud IC plus cloud to cloud CC to cloud to ground CG is in the ratio IC plus CC, CG equals 3:1. The base of the negative region in a cloud is normally at roughly the elevation where freezing occurs. The closer this region is to the ground, the more likely cloud-to-ground strikes are. In the tropics, where the freeze zone is higher, the IC plus CC CG ratio is about 9:1. In Norway, at latitude 6-N, where the freezing elevation is lower, the IC plus CC CG ratio is about 1:1. Distribution. The map on the right shows that lightning is not distributed evenly around the planet. About 70% of lightning occurs on land in the tropics, where the majority of thunderstorms occur. The North and South poles and the areas over the oceans have the fewest lightning strikes. The place where lightning occurs most often, according to the data from 2004 to 2005, is near the small village of Kifuka in the mountains of Eastern Democratic Republic of the Congo, where the elevation is around 1,700 meters, 5,600 ft. This region received 158 lightning strikes per square kilometer, 409 per sq mi a year. Above the Catatumbo River, which feeds Lake Maracaibo in Venezuela, Catatumbo lightning flashes several times per minute, and this place has the highest number of lightning strikes per square kilometer in the world. Malaysia has one of the highest rates of lightning activity in the world, after Indonesia and Colombia. The city of Teresina in northern Brazil has the third highest rate of occurrences of lightning strikes in the world. The surrounding region is referred to as the Chapada do Carrasco flash lightning flatlands. In the United States, the West Coast has the fewest lightning strikes, and Florida sees more lightning than any other area. In 2018, 14 Florida counties ranked in the top 15 counties in the United States for having the highest lightning density. Florida has the largest number of recorded strikes during summer. Much of Florida is a peninsula bordered by the ocean on 3 sides with a subtropical climate. The result is the nearly daily development of clouds that produce thunderstorms. For example, Lightning Alley, an area from Tampa to Orlando, experiences an extremely high density of lightning strikes. As of 2007, there were as many as 50 strikes per square mile, about 20 per km2 per year. In their 2018 annual lightning report, Vaisala reported there were as many as 24 strikes per square mile, about 9 per km2 per year in Florida. The Empire State Building in New York City is struck by lightning on average 23 times each year, and was once struck 8 times in 24 minutes. Lightning data sources. Before technology was developed to accurately detect and record lightning flashes, climatologies were based upon the number of audible detection of thunder. The coronic or saronic level was the average number of days per year when thunder was heard in a given area. A map of isochronic contours was used to give a rough estimate of relative lightning frequencies. However, variations in population, the distance sound travels due to terrain made such maps quite spurious, and human hearing made such maps imprecise. It also could not hope to differentiate between different types of lightning. Electronic lightning sensors advanced during the 20th century using radio wave disruptions. Originally, the expense of such instruments caused only sporadic development. However, a small set of sensors in the U.S. employed during a 1979 project by NOAA's National Severe Storms Laboratory grew into the National Lightning Detection Network (NLDN), achieving nationwide coverage in 1989. Vaisala is now the operator and primary distributor of data from the NLDN and developed the Canadian Lightning Detection Network (CLDN) as of 1998. The Euclid network is the European shared network, covering most of the continent apart from some Far Eastern nations. Collaborative amateur development spurred the formation of the Blitzertung community, which offers real-time lightning strike data from most of the world as well as historical data dating back to 2008 under the Creative Commons license. Satellite lightning measurements began in 1997 when NASA and National Space Development Agency (NASA) of Japan launched the lightning imaging sensor LIS aboard the TRMM satellite, providing periodic scan swaths over tropical and subtropical portions of the globe until the satellites was lost in 2015. In 2017, NOAA started deployment of geostationary lightning mappers aboard their GOES-class satellites, offering continual coverage of much of the land within the Western Hemisphere. Maps of the U.S. lightning strike/KM2 averaged from 1997–2010 are available from VASAL's webpage for a fee. More detailed U.S. regional lightning maps based on the National Oceanic and Atmospheric Administration (NOAA) and the National Weather Service (NWS) data centered on different cities are put out by the Cooperative Institute for Applied